Okay, now I'll start on kinematics. Okay, for this, I'm not really gonna do so much on with regards to the topic as a lesson, but we'll be focusing more on how to answer questions. Okay, we're talking about answering questions. Okay, answer questions. So now, first thing before we start on us trying to answer questions, you must know that kinematics we are dealing with three things that we have here. First one, we are dealing with distance. Okay, so you look at most of the questions, they may ask you to calculate what's the distance traveled. The next one we're going to talk about in kinematics, we talk about speed. Okay, they're going to ask what is the speed which the object is traveling. And last one, we talk about acceleration. Okay, so these three are the key things here. Now, with regards to distance, sometimes you might see this word called displacement. Okay, with regards to speed, you may see this thing called velocity. In your syllabus, normally you just need to know that distance is a scalar, displacement is a vector. Same thing, speed is a scalar, velocity is a vector. Well, acceleration is a vector. So this highlighted in green, green equals to vector. Okay, for those highlighted in yellow, that is a scalar. Highlighted in yellow is scalar. Now, these are the few things that they will always ask you to calculate and always find out. Okay, now we're going to deal with how to do each of these questions here. Okay, we're going to deal with how we're going to tackle each of these questions. First up, let's start off with speed. With distance. Okay, so let's delete this. Now, distance. Okay, how to tackle when they ask you calculate the distance traveled. Okay, for this here, there's generally two ways to find out. First one is by using the formula. Okay, first one is by using formula. Okay, you know that for distance is equals to speed times time. Take note that this speed here is a constant speed. Okay, if it is not a constant speed, you have to use the second method. Okay, so take note, distance equals speed times time. The speed here must be a constant time, and the time here must be the time taken. Okay, time taken. So now, example, okay, we talk about maybe an object travel at a speed of 30 meters per second, and say maybe for 2 seconds. Travel speed of 30 meters per second for 2 seconds. So find the distance. It's traveled. Okay, very simple questions here, but first thing you must always highlight the necessary stuff. 30 meters per second refers to the speed, while the 2 seconds here refers to the time. So when they ask you to calculate the distance traveled, same thing, please make sure always write your working down. Okay, write your working down. So distance is equals to 30 meters per second, because that's the speed, multiplied by the time, which is 2 seconds, equals to 60 meters. So this is the first way of how we can go about doing distance. Okay, this is how we can go about doing distance. The second way that we can go about finding out distance is by using the graphical method. Okay, so first one we did was on formula. Next one we're gonna go by graphs. Okay, we're gonna go using graphs. Okay, now when you talk about using graphs, we got two types that we always deal with. We got a displacement time graph. The other one is your speed time graph. The distance traveled, okay, if let's say I'm using a displacement time graph, okay, maybe the time, it looks like this. So generally, if you got this kind of a graph, a displacement time graph, the distance traveled is equals to the y value. okay, equals to the y-axis value. So example, maybe I want to say that what's the distance traveled? Example question, example. Distance traveled at 30 seconds. Okay, so I'll find out where's 30 seconds. Maybe 30 seconds is here. So I'll draw a dot, 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 dot. And this value over here, maybe is 100. So the distance traveled at 30 seconds equals to 100 meters. It means that at 30 seconds, my object has already traveled 100 meters. Okay, take note of the units here. For me, in this case, I'll put seconds and meters here. Okay, this is with regards to using the displacement time graph to calculate distance traveled. How about if you get a speed time graph? If you got a speed time graph, the way how we're going to do it is slightly different. So same way of how the graph looks like. Then the units we're going to give is meters per second. Let's use the indices way of writing it. Time, we put it in seconds. Okay, now to calculate distance traveled for this type of speed time graph, the distance traveled is equal to the area under the graph. Okay, so I want to say that find the distance. So example, what's the distance traveled from 0 seconds to 30 seconds? Okay, so maybe we put 30 seconds here again. Sorry, remove the seconds here. So what I'm going to do is, I'll do something like this. Maybe I say it's 10 meters per second. Okay, how do I find out? So in this case, for the distance traveled, what I need to do is I need to calculate the area under the graph. So I need to calculate this area of the triangle. Okay, so what's the area of the triangle? So area here is equals to half times 30 times 10. Half times base times height. This is equivalent to 150 meters. Okay, sometimes it may be a triangle, sometimes it may be a trapezium. Okay, example of trapezium can be looking like this. Okay, so from maybe 0 to 60. So you can see my area under the graph now looks like this. So this becomes a trapezium. So you just need to calculate the area under trapezium. Find the values here. Maybe this one is 15. Then from there, you can once again calculate the distance traveled. So for distance here, you got two ways of doing it. How to calculate? First, by using formula. Okay, distance equals to speed times time. The other way is using the graph. Two types of graph here, displacement time, speed time. Well, displacement time is just the y-axis value. Okay, looking at the y-axis value. Whereas for the speed time graph, you have to calculate the area under the graph. So it's a bit more complex. So this is the end of the introduction and also finding distance in your kinematics question.